Certainly the perchlorate is likely to play a role in how dry the soil is. Water vapor will come off the ice, for example. The perchlorate will tend to suck it up. It's a desiccant. And we are thinking that may well be part of the picture. We say dry, not because there isn't ice there, not because there isn't H2O, but because there isn't anything in the form of even very thin films of liquid water that might exist at cold temperatures and mixed with salts. So when we landed, we didn't know whether we'd find different types of liquid or just dry soil and ice underneath it. And right now it seems like it's dry soil and ice underneath it.
Thanks, Mike. Now, next in the queue is Ann Menard with National Geo News. Ann?
Hi, thank you. This is another question sort of about the new news. There have been a couple of studies coming out lately that are finding evidence for a wet Mars either in the first billion years of its history or even in the billion years after that. For Bill or Mike, do you have any idea of the timing of the wet interactions that would have formed the carbonates and the possible silicates? And then Peter referenced a possible melt phase. Could the melt phase have coincided with that or been another opportunity for a wet Mars and for life to form?
Okay, I'll begin with that. From my standpoint, I don't think I could really hazard a guess on when this might have happened. This is the kind of thing that might actually have to wait for some time in the future when we actually bring samples back from Mars and can date them and things like that. But I don't know, Mike, if you want to add anything to that.
Really, no, nothing I could add to that.
Okay, let's go back to Sally Rail, Planetary. Sally, are you with us?
Hi, thank you. I just wondered if you could go through a checklist of what needs to be done still for mission success. To Doug or Peter?
Peter, why don't you start?
Well, we wrote in our proposal that we would attempt to measure organic materials in the soil, and part of that measurement is to get our organic-free blank that we brought with us from Earth. That sets the zero line, if you like, as to where terrestrial organic contamination exists on the spacecraft. And then if we measure a considerable amount above that in some of our cells, in some of our ovens, I mean, then we can start to talk about Martian organics. Now, Martian organics don't necessarily mean these are biological systems. Could well be that the organics were brought by comets or asteroids to the surface of Mars and preserved in the ice. So we have that yet to do. We haven't measured the blank, and we haven't compared it with the measurements of our cells. So that is one thing. And the other is we're really interested in the isotopic ratios of the water vapor and the water ice. So comparing the deuterium to hydrogen ratios in the soil, and in the ice in the soil and into the atmosphere are going to tell us if these systems are working together. We have a reservoir of water vapor, a reservoir of ice. Are they really interacting, or is there some of this ice perhaps from an ancient time or another time from the past and therefore out of balance? So those two things come to mind quickly as something we want to do. And finally, completing our climate and weather observations, our study of the atmosphere throughout the entire length of the mission is a prime goal. So those things are left.
Doug, you want to add anything to that?
The only thing I'd like to add is that NASA sets specific mission success criteria in what's called the Level 1 requirements. It sounds rather technical, but the point is when we design a mission or go out and have someone fly a mission for us, we define what we want out of that mission through those documents. The Phoenix mission actually accomplished all of its full mission success criteria in late August, so they're completely done and meeting all the Level 1 requirements in that regard. So this is extended mission. This is great new science, great addition to the basic mission that NASA was looking for at the beginning. And so this is where these guys are headed. Good news.
Thank you, Doug. And I believe we're going to go back to the Johnson Space Center for a question.
Thanks. It's Mark Carreau from the Houston Chronicle, and I had two questions. I'm wondering if you can kind of dial back to the start of the briefing and estimate how long you think Phoenix can last electrically into this extension that you've approved. Is it a matter of a few weeks, or is it maybe past the end of October? I just wondered if you could sharpen the estimate a little bit.
Peter, did you want to start, or you want to send that out to Barry?
I think that's a Barry question.
I think I'll handle that here in Pasadena. We have been modeling both the consumption of energy as well as the production of energy, and we actually have been correlating and basically verifying those models are correct by measuring how much energy the vehicle produces every sol. And basically what we see is we see a downward sloping curve, as you would expect, with the sun going down below the horizon for longer and longer per sol. And based on those estimates and based on those predictions we have, it looks like we meet the point where the production needs crosses the, I should say the consumption needs crosses the production curve, looks like somewhere at the end of November. The accuracy of that is obviously a little bit fuzzy as you go on every sol. It varies a little bit. But we feel confident that the vehicle will survive all the way through the mid to latter part of November. Now, given the fact that we err on the side of conservatism many times, it's quite probable that we'll last beyond that point. Now, whether we'll last beyond that point a couple of days or a couple of weeks are the issue in question. It's not as though the vehicle is going to survive a number of months past the end of November. So right now we put together a plan to operate the vehicle as a weather station in the months of November and December. I find it very unlikely, considering our models are being validated every sol, that we will have enough energy to go beyond that point.
Do you have a follow-up?
Boynton. Yes, one more question for Dr. Boynton, I think. I guess I wanted to understand what your best chance now is to see organics if they're there. Is it through the use of the remaining TIGA ovens, and is that in fact, I just want to make sure I understand that's what you hope to do with the ovens is to search hard for that if it's there?
Yes, we will be looking hard for the organics, and it's one of the things for all of the remaining samples that we're going to be putting in there. We will be looking for the organics and analyzing for those masses in the evolved gas analyzer. So we are going to give it our best shot in every one of the future samples we do.
Okay, folks, we are going to bring it to a close here. I want to thank our participants. We will be replaying the visuals that were presented during the presentations. Of course, you can go to www.nasa.gov/Phoenix for the latest developments. And on a programming note, there are some developments with the Hubble resurfacing mission. There will be a media telecon at 6 p.m. Eastern today. Call your respective NASA Center newsroom or headquarters newsroom at 202-358-1600 for details, or go to the website. Again, congratulations to the Phoenix team. It has certainly been an exciting time, and science never sleeps, and science is definitely very active today. Thanks for joining us.